CMIC 3, Unit 5, Test 4. This is our worksheet that we are doing, getting ready for our quiz, which will tell us if we're ready for Test 4 or not. Problem number 1. The instructions say identify points of discontinuity, holes, vertical asymptotes, x and y intercepts. You also need to find the horizontal asymptotes in order to sketch the graph, which is the final thing in the instructions. So step 1. Factor the numerator and the denominator, or factor the rational function. You should write these steps down as well. So I'm going to factor. First of all, I'll factor the numerator. I have negative 2x squared plus 6x. In order to factor something, I need to get x squared by itself. So I'll have to divide both of these by negative 2. Negative 2x squared divided by negative 2 would be x squared. I can also divide both by x, though. I have an x in both of them. So I'm going to factor out a negative 2x. So I'm going to divide this by negative 2x, and then multiply the whole thing by negative 2x. I just get x. 6 divided by negative 2 is negative 3. X divided by x is 1. I have x minus 3 in the numerator, negative 2x times x minus 3. In the denominator, I have to factor a trinomial. I cannot divide all of them by x, and there's no number that I can divide all of them by. So I end up with two binomials. I will need x's to get x squared. I need to get a positive number, so I either need two positives or two negatives. But when I add the two, I need to get a negative number, so I know I need negative, negative. I need to multiply to get 3, add to get 4. So that's 3 and 1. Negative 3x minus 1x give me negative 4x. Negative 3 times negative 1 gives me positive 3. I've got my factored form now. Step 2. Find the discontinuities. And you should be writing these down as well. You'll be able to use these notes on the test and on the quiz if you write them down. Where the denominator equals 0. Okay. If I look at this problem, if I make x 3, 3 minus 3 would be 0. My denominator would be 0. 3 minus 1 would be 2. 0 times 2 is 0. My calculator will give me an error because I cannot do that. The other option is x equals 1. 1 minus 3 is negative 2, but 1 minus 1 is 0. 0 times negative 2 is 0. I would get a 0 in my denominator. So these two values of x cannot be used with this rational function. If I try to put them in this rational function, I do not get an answer. That's why we call them discontinuities. Step 3. Identify whether the discontinuities are vertical asymptotes or holes. Vertical asymptote is where it goes to infinity. And I'm going to think about getting close to -1. If I get close to -1, for instance, if I'm at 1.1, I will have, in this function here, -2 times 1.1 times 1.1 minus 3 divided by 1.1 minus 3. Since I do not have a 0 in the denominator, these two can cancel. And that's going to be important in a minute. Then I have 1.1 minus 1. This is going to give me 0.1. So I have -2 times 1.1 divided by 0.1. So this dividing by a small number is going to make this number get bigger. If I think about x equals 1.01, and once again, since x is since this is not 0, these two are going to cancel. Now I'm going to have -2 times 1.01 divided by 0.01. Now as I keep going, this is going to get closer to 1. If I do 1.001, this will get closer to 1. My numerator is going to get close to -2, but my denominator is going to get smaller and smaller. That's going to make y bigger and bigger. So as I get close to close to 1, y is going to go to infinity. So this is a vertical asymptote. Asymptotes mean the function goes on forever and gets closer and closer to that line, but it never touches. As I get close to 1, I'm going to get closer and closer to -2, but I'll never touch it. So this is a vertical asymptote. If I go back and look at this, where x is getting close to 3, I have -2 times 3.1 times 3.1 minus 3 divided by 3.1 minus 3. Those will cancel. Then I have 3.1 minus 1. So I get this equal -2 times 3.1 divided by 2.1. I'm not getting closer and closer to 0. If I keep going, I get 3.01. I'll multiply by 3.01 here. I'll have 2.01 here. 3.01 minus 1. So this is going to get closer and closer to 3. This is going to get closer and closer to 2. This is going to stay at -2. So actually, I'm going to end up looking like something very close to -2 times 3 divided by 2. So this is actually going to get closer and closer to, as x gets closer to 3, let me write that, as x gets closer to 3, y gets closer to -3. We'll use that later on, but the point is we're not going to infinity. So x equals 3 is actually a whole because I can cancel these two. Step 4. Find the x-intercept. Let's find the y-intercept first. And the y-intercept is where x equals 0. So I'm going to go back to my equation. You can use either form of the equation, the factored form or the standard form. I'm going to think about the standard form. I have negative 2 times 0 squared, that's 0. 6 times 0 is 0. 0 plus 0 is 0, so my numerator is 0. As long as my denominator is not 0, my answer will be 0. 0 times 4 is 0. 0 squared is 0. 0 minus 0 plus 3 will give me 3 in the denominator. So I end up with 0 over 3. So for my y-intercept, I have y equals 0 over 3, or y equals 0. And I'm going to put that on the graph. When x is 0, y is 0. So I've got something on my graph already. Step 5. Find the x-intercept. This is where y equals 0, which is going to be a little bit more complicated. So y, or f of x, equals 0. And I'm going to go to my factored form now. If I look at my rational function, the way to make the rational function 0 is to make the numerator 0. We got 0 for y because my numerator was 0. So my numerator has to be 0. One option, as we found, was to make x 3. So x equal 3 would make the numerator 0. But I cannot use x equal 3 because that's a discontinuity. I cannot put x equal 3 into this. So I cannot say that x equal 3 is an intercept. That's going to be my whole. And we'll do that. We'll use that in a moment. But for now, the only way to make the numerator 0 is to make x 0. So I say x equals 0. Gives me my x-intercept. So the only place I cross the x-axis is at x equals 0. So that's this point as well. Okay, step 6. X-intercept, y-intercept. Now I need to find the horizontal asymptote. To do that, I'm going to look at my end behavior. As x approaches infinity, what happens to y? What happens to f of x? If I look at my factored form, I can say infinity is going to be a very large number, or infinity is not a number, but as I approach infinity, I'm going to be dealing with large numbers, numbers that are much bigger than 3, much bigger than 1. So this is really going to look like x squared in my numerator, because I can approximate x minus 3 with x, because x minus 3 is going to be very close to x. So I can say this is approximately x squared. And my denominator is also approximately x squared. So I have negative 2x squared divided by x squared. The x squareds cancel. Negative 2 times x squared over x squared, which equals negative 2 when those cancel. I can look at my my standard form as well. I can say that x squared, when x is very large, x is going to be much larger than 6x. In the denominator, x is going to be much larger than negative 4x. I can ignore these terms when I'm talking about my end behavior, and I get negative 2x squared over x squared. They cancel. At any rate, as x approaches infinity, y approaches negative 2. So my horizontal asymptote is x equals negative 2. So I will draw that in. Step 7. Sketch the graph. To do that, I need to put all the things on that I have not put on yet, but all the things that I've calculated I need to put on. Sketch the graph. First of all, I've put my horizontal asymptote on. I've put my y-intercept on. I've put my x-intercept on. I need to put in my discontinuities. So at x equals 1, I have a vertical asymptote. So I will put that line in there. I need to approach that, but never touch it. At x equals 3, I have a hole. So at 3, I have a hole. And I'm going to go back here and look at what I did when x equals 3. I was just talking about what happens as x gets closer and closer to 3. This is going to get closer and closer to 3 over 3.1. So 3.1 over 3.1 minus 1. So this is going to get closer and closer to 3. This is going to get closer and closer to 2. I canceled those out. As x approaches 3, y approaches negative 3. So when I'm at x equals 3, my y is going to be approaching negative 3. So I actually have a hole here, and I show that with the circle. I have that hole because the curve comes up to that point, but it doesn't cross that point. So I go from that point, and I go out here approaching my horizontal asymptote. I go out this way approaching my vertical asymptote. I take my y-intercept, also my x-intercept, and I approach that vertical asymptote, and I approach the horizontal asymptote, but I never touch them. That's how we sketch the graph.